Hi guys, salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about dynamics of rigid bodies. At ngayon ay ipagpapatuloy natin guys ang ating discussions about curvilinear motions. At pupuntahan muli natin itong ating second problem guys. Ang problem natin is all about a stuntman who is to drive an auto across the water filled gap that is shown in the figure. We are required here to determine the auto's minimum takeoff velocity and the angle of the landing ramp to avoid impact. So guys, ganito yung situation So itong car will be crossing a water filled gap, okay? Having a gap of 40 meters horizontal gap between the takeoff ramp and the landing ramp. At meron din siyang vertical clearance or vertical gap between this point and that point. So kung itong auto will be crossing safely the gap, the question is what should be the takeoff velocity of this car, okay, and what should be the inclination of this ramp in order to avoid the impact. Okay? Siguro guys, mas makatutulong sa atin kung na-visualize natin kung ano ba yung mangyayari sa car kapag nag-cross siya, okay, in the water filled gap. At ipakita natin yung mangyayari sa kanya. Ganito yung scenario guys, Okay, so kapag pagdating niya dito, lilipad ngayon siya, okay, and then mag-fall siya exactly at the ramp, okay, without impact. So the question is, ano dapat yung kanyang velocity dito, okay, at ano dapat itong inclination itong landing ramp so that the impact is avoided. So para maunawaan natin guys kung paano sosolving, ay makatutulong siguro sa atin kung i-analyze natin yung scenario, ganito yung mangyayari kasi una, yung inclination ng ramp at takeoff, ito yun, ito yun daw yung magiging direction or inclination of the takeoff velocity. Kaya kung yung car will be running at that speed, diba? So at this point, okay, the car will be given an inclination, a velocity inclined, okay, with the same inclination as the takeoff ramp. If this takeoff velocity will be resolved into component along the y and along the x-axis, hence yung kanyang velocity in the y direction will be given as v sub oy. Samantalang ito naman kanyang velocity along the x-axis or the component of the velocity along the x-axis will be given as v sub ox. And these two components can be expressed in terms of the velocity and its direction, kasi nga binabanggit dito na yung direction itong takeoff velocity will be equal or will be the same as the inclination of the takeoff ramp. Kaya kung itong ramp ay mayroong inclination na 1 vertical to 2 horizontal, hence this inclined distance would have a square root of 5. And therefore from here, ay madidefine natin ngayon itong component ng velocity in the y and in the x direction, so that this y component of the velocity would be equal to 1 over the square root of 5 of the takeoff velocity. At samantalang ito namang horizontal component ng velocity will be equal to 2 over the square root of 5 of the takeoff velocity. So, pagkatapos niya, kung sakaling lumipad na siya that direction, okay? So, when it landed this ramp, okay? So, dapat, okay, para ma-avoid yung impact, yung impact as the car lands on the ramp, then the ramp must have an inclination equal to the angle of inclination of the landing velocity. Kumbaga, dapat para maiwasan yung impact, ito daw ramp na ito ay mayroong inclination that is the same as the inclination of the landing velocity. Kaya kung ito ay mayroong landing velocity na v sub 2 which is inclined in this direction, diba? Hence, this inclination must be parallel to that direction of the landing velocity. So that if we would be expressing the component of this final velocity or landing velocity into horizontal and vertical, so that this v sub 2x will be the landing velocity, the component of the landing velocity in the x direction, while this direction will be the component of the landing velocity in the y direction. Therefore, okay, the inclination of this landing ramp can be taken as the ratio of the vertical component of the final velocity to the horizontal component of the final velocity. Hence, masosolve natin itong inclination kapag nasolve natin therefore itong kanyang components of the landing velocity. Kaya, sa scenario na ito, okay, masosolve natin yung problem by taking first the initial velocity. And to do that, okay, we will be resolving the elements of the motion into horizontal and vertical components. Kaya kung kukunin natin yung initial velocity along the x-axis, so we will have here the v sub ox, di ba? At alam naman natin na yung displacement of this car in the x-axis would be equal to s sub x, di ba? And the formula of that s sub x will be equal to v sub ox multiplied by t plus 1/2 of ax times t squared. Sa equation na ito, ito yung equation ng relations ng element along the x-axis, where s sub x will be the displacement of the auto or the car in the x direction. And if it is to clear the gap, therefore the horizontal displacement of the car from the takeoff to the landing would be equal to 40 feet, and that would be taken at positive, diba? Because it is located to the right of the original position of the car, or the initial position of the car as it take off the ramp. And so the initial velocity of the car in the direction of the x-axis represented by v sub ox will be equal to 2 over the square root of 5 of v sub o. At ito nga yun, So ano ngayon ang ating acceleration? Because there is no mention that there are factors that affects the horizontal movement or velocity of the velocity, therefore acceleration in the x direction will be equal to 0. And so from here, we can substitute the value of s sub x, the expression of v sub ox in terms of v, as well as the acceleration. And so that if we are to substitute the values, we shall be getting the relationship between the time and the initial velocity, meaning the time that the car would be traveling along a horizontal distance equal to 40 feet. And so that we have time equals 20 multiplied by the square root of 5 divided by the initial velocity. Or from here, we can also express the other way around, that the initial velocity will be equal to 20 multiplied by the square root of 5 over the time t. And let us try to consider that this is our force equation. So similarly, we can analyze, we can express, or we can analyze the situation along the y-axis, so that if we will be solving for the displacement of the auto along the y-axis, therefore s sub y will be equal to v sub oy plus 1/2 of a sub y multiplied by t. So from here, the s sub y will be equal to a negative 10, as this would represent the clearance between the takeoff ramp and the landing ramp, the vertical clearance. And the sign is given as negative because the landing ramp, or this final position of the auto, is 10 feet lower than the initial position. It is located below the initial position, hence we consider for convention the sign of negative. Similarly, our v sub oy will be equal to the vertical component of the initial velocity, which is directed in the upward direction. Hence, it will be treated as positive. Okay, we also have our a sub y representing the acceleration due to gravity. And because it is directed downward, therefore, for convention, we shall be using a sign of negative for the acceleration. So that, okay, our acceleration will become equal to negative 32.2 feet per second squared. And if we substitute the value in this equation that for s sub y, therefore our s sub y, our equation becomes negative 10 being equal to 1 over the square root of 5 multiplied by v sub o, a multiplied by t, minus 1/2 of 32.2 t squared. But we already have expressed the value of v sub o, okay, which is equal to 20 the square root of 5 over t in the relation, okay, of the initial velocity and time taken when we analyze the component in the x direction of the motion. And so if we were to substitute that value, we shall be getting the equation that negative 10 is equal to 1 over the square root of 5 multiplied by 20 the square root of 5 over t. This value is actually our initial velocity multiplied by t minus 1/2 of 32.2 t squared. And so from here, we can solve for the value of time t, the time required for the car to land on the landing ramp. And so the time is equal to 1.365 seconds. After we have computed for this t, we can now solve for the initial velocity by substituting that in the equation 1, that our velocity is equal to 20 the square root of 5 over t. Now substituting the value of t equal to 1.365 here, therefore our initial velocity will be equal to 32.763 feet per second. Now after we have solved for the initial velocity, we now compute for the required inclination of the landing ramp in order to avoid impact of the car while landing on the ramp. And as we have analyzed, this inclination of the landing ramp can be taken from the magnitude of the components of the velocity of the car as it lands on the ramp. So what shall we be doing therefore is to determine the magnitude of the components of the landing velocity, in the x and in the y direction. So that, if we are to solve for the final velocity along the x, we will have the formula that the final velocity is equal to the initial velocity plus the product of a multiplied by t. And so substituting the value of v sub ox, we have here 2 over the square root of 5 multiplied by the initial velocity of 32.763 plus the acceleration is 0 along the x-axis, and hence we can solve for the final velocity along the x-axis v sub 2x equal to 29.304 feet per second. Similarly, we can compute for the y component of the final velocity such that our y component will be equal to v sub oy plus a sub y multiplied by t. Again, we have computed for the initial velocity, and the component of that initial velocity in the y direction is equal to 1 over the square root of 5 multiplied by that v sub o. So that if we will be substituting that value here, so we have here the final velocity in the y direction will be equal to 1 over the square root of 5 multiplied by 32.763 plus the quantity negative 32.2 representing this acceleration due to gravity, which is directed downward, multiplied by the time t of 1.365 seconds. And from here, we shall be getting the component in the y direction of the final velocity equal to 29.309 feet per second. And because we wanted to compute for the inclination of this ramp, hence the ramp would be inclined at an angle theta whose magnitude will be equal to arctangent of v sub 2y over v sub 2x. So that if we will be substituting the value of v sub 2y representing this magnitude of 29.309 and v sub 2x of 303. Hence, our angle theta will be equal to 45 degrees. And so that is how we'll be able to solve, we'll be solving the problem of the magnitude of the takeoff velocity as well as the inclination of the landing ramp. Okay, maybe we can now move to our third problem, and the third problem ay ganito yung scenario, no? So here is the sample problem number 3, and the problem states that a rocket is released from a jet fighter flying horizontally at 75 miles per hour at an altitude of 8,000 feet above its target. The rocket thrust gives it a constant horizontal acceleration of 0.6 g. Determine the angle between the horizontal and the line of sight to the target in order to hit the target. So, ganito yung scenario, guys. Mas mabuti siguro kung isa-isahin natin yung given, and from the given we try to imagine and draw our situation. So meron tayo ditong plane or jet that is flying horizontally at 750 miles per hour. So imagine natin ito yung jet, and the jet is traveling a horizontal direction of 750 miles per hour. If this will be converted into feet per second, this will be equal to 1,100 feet per second. Imagine how fast the jet is flying, 1,100 feet per second. Okay, so what else is given? Okay, the jet is traveling at an altitude of 8,000 feet above its target. Imagine natin that we have here a target, okay, and the target is somewhere here, okay, whose distance is 8,000 feet below, okay, the elevation of the jet. So the distance from this point is given as 8,000 feet. Now the question is that, okay, there is also given that the rocket, okay, will be subjected to a horizontal acceleration once released, and the magnitude of that acceleration is 0.6 g. So if the rocket will be released, it will now be subjected to a horizontal acceleration of 0.6 multiplied by g, and that acceleration, when translated into feet per second, will be equal to 19.32 feet per second square. Now, on the question of the angle between the horizontal line of sight and the target, in order to hit the target, ito yung ating tinatanong. We are being asked here to find for this angle, that this line of sight from the jet to the target and the horizontal line will be making this angle. Okay, in order for the target to be hit, once this is seen to have this angle, the rocket will be released. Okay, and what will happen? Ano ba mangyayari kapag na nirelease natin? Parang ganito yung mangyayari, no? Subukan natin na mag-release ngayon ng rocket and see what will happen to the target. Ito yung mangyayari. Okay, so a rocket is released, and then the target is hit by the rocket. The question is, at what angle, okay, bago i-release yung rocket, para masigurado na yung target ay tatamaan. Diba? Assuming natin that this distance will be our S sub y, and this distance will be called as S sub x. And hence, ang tangent theta can be taken as the arctangent of S sub y over S sub x. And because we are already given S sub y, we only need to solve for S sub x in order for us to solve for the angle theta. And what shall we do? Okay, tingnan natin, Okay, makatutulong kasi na maunawaan natin yung konsepto na if there is a rocket that is released from this point, yung time required for the rocket to move a vertical distance of 8,000 feet shall be the same time required for the rocket to travel the horizontal distance of S sub x. Diba? So, unahin natin ngayon yung vertical component of the motion. That, okay, if you will be solving for t, we know the formula that S sub y is equal to v sub oy plus 1/2 of a sub y multiplied by t squared. We know that S sub y represents the vertical distance between the target and the jet. And because the target is located below the jet, therefore S sub y will be treated as negative, and the value will be negative 8,000 feet. Okay? Our v sub oy, the vertical component of the velocity, will be 0 because it will be dropped from the jet. There will be no initial velocity as it is to be released from the jet. Similarly, our acceleration will be equal to 32.2 feet per second, as this would represent the acceleration due to gravity and the direction is downward. Hence, it will be considered to be negative in our convention that all those elements that is directed downward will be negative and upward positive. Okay, so from here we can now solve for the time t, so that if this will be substituted to equation, okay, our equation becomes, okay, negative 8,000 equal to 0 multiplied by t plus 1/2 of negative 32.2 t squared. And so from here we can solve for the magnitude of t, or the time required for the missile or the rocket to drop a distance of 8,000 feet, and that is equivalent to 22.2911 seconds. And this time t, which is equal to 22.2911 seconds, shall be the same time t that will require, okay, a distance of s sub x. And so from here we can solve for the horizontal distance that will be traveled, okay, during the time t equal to 22.2911 seconds. And so solving for that s sub x, okay, so s sub x by the formula is equal to v sub ox plus 1/2 of ax multiplied by t squared. Substituting the value of t equal to 22.2911 in this equation, so our s sub x will become equal to, okay, 1,100 multiplied by 22.2911 plus 1/2 of 19.32, okay, multiplied by 22.2911, okay, square. So that from here we can solve for s sub x equal to 29,320.2 feet. And because we are asked to solve for this angle theta can be computed by substituting it in the value that theta is equal to arctangent of the s sub y over s sub x, so that theta by computation will be equal to 15.261 seconds. I hope guys got that with the two problems that I presented to you, help you understand the concept of curvilinear motion, and let you know, okay, the easier way of dealing with them using the concept of the rectilinear motion. Guys, sana ay patuloy nyo akong subaybayan sa ating ginagawang discussions by subscribing to this channel, so that whenever there will be new uploads, you will be notified of my lectures. Once again, thank you very much for watching.